Hello girls, I hope you're staying safe at home. So today we are going to start with a new chapter, that is the periodic table. Okay, now periodic table is nothing but it is a table where elements are classified in such a way so that their comparative study becomes easier. So the reasons for classification of elements was to help in the studying of elements in an organized manner. Okay, so that was the first reason. Then it also helps in correlating properties of elements with the fundamental properties of all states of matter. Now you know states of matter means solid, liquid and gases. Okay, and the third reason was it helps in defining the relationship of one element with another element, that is relationship between elements. So these were the three reasons for classification of elements. Now in the beginning, many attempts were made by chemists to classify elements on different factors such as density, malleability. If you remember, malleability means to beat them into sheets without breaking. Ductility means they can be drawn into wires. We are talking about the, properties of metals. And also another properties taken were whether they were metals or non-metals. But these early classification was unsatisfactory. Why? Because the number of elements was very large. When in one group there were a large number of elements. Okay, so of course study became very difficult. Okay, then next, some of the characteristics being considered was different under different conditions. So whatever characteristics of the elements were taken, it was different under different conditions. Like, of course, like at a certain temperature or at a certain pressure, it was different. Okay, and also certain elements showed metallic as well as non-metallic characteristic. That means they were basically metalloids. That means showing properties of both metals and non-metals. So the scientists were actually in the search of a characteristic of an element that would never change. So finally it was William Prout who discovered that the atomic mass of an element never changed. So it could form a scientific basis for a satisfactory scheme of classification. Next, we move on to Dobereiner's triad. Okay, now J.W. Dobereiner was a German scientist. He observed that certain elements showed similar properties and they could be placed in a group of 3 elements, and these 3 elements were called triads. Tri means 3, you know that. So the 3 elements of a particular triad had similar chemical properties. Actually, Dobereiner was the first scientist to show the relationship between properties of an element and its atomic mass. Now, the 3 elements placed were in such a way, supposing these were the 3 elements A, B and C, it was seen that the atomic mass of the middle element was approximately equal to the average of these 2 elements at the side. Okay, so example, if we take 3 elements, calcium, strontium and barium, you will see that all these are metals, all 3, and the oxides of all these 3 metals, that is calcium oxide, strontium oxide, barium oxide, were alkaline in nature, and all 3 had a valency 2. All 3 has valency 2. Okay, so these elements, they had similar properties, so they were put together in a group to form the triad. Okay, and you will see that if we take 40 of calcium and 137 of barium and divide by 2, we will get 177 divided by 2, which is equal to 88.5. So approximately it was equal to the atomic mass of the middle element. Okay, so again, if we take another 3 elements, chlorine, bromine and iodine, all 3 are non-metals, all react with water to form acids, and all have valency 1. That means the properties were the same. Okay, similar properties. So again, if we take 35.5 plus 127 divided by 2, okay, we get 162.5 divided by 2, which is equal to 81.25, which is approximately comes to 80. Okay, but what happened is this law of triad was discarded. Why? Because all elements at that time could not be arranged in threes. Okay, that is Doberanus triads. Next is the law did not apply even within the same family. Now the halogen family, if you see fluorine, chlorine and bromine, okay, if we add 19 plus 80 divided by 2, we get 49.5 and not 35.5. Okay, so it failed even within the same family. Okay, so Doberanus scheme of classification of elements was not successful because it did not contain many principles which were supposed to be shown by the various elements. After the law of triad was discarded, Newland came up with the law of octaves. Now, John Newland was a scientist as well as a lover of music. So he arranged elements in ascending order. Ascending order means increasing order of atomic mass, and found that every 8th element had properties similar to the properties of the first element, just as the 8th note of a musical octave is the same as its first note. So he observed this, so Newland gave his law of octaves for classification of elements. So according to this law, that is the law of octaves, when elements are arranged by increasing atomic mass, the properties of every 8th element starting from any element are a repetition of the properties of the starting element. Now you know in music, do, re, mi, fa, so, la, ti comes back to do. In Indian music also, sa, re, ga, ma, pa, dha, ni again comes back to sa. So 1, 2, 3, 4, 5, 6, 7, 8 coming back to the same. Again same here, 1, 2, 3, 4, 5, 6, 7, 8 is coming back to the first. Okay. So Newland divided the elements into horizontal rows of 7 elements each. Okay, the noble inert gases at that time was not discovered. Okay, so what were the merits of Newland's classification? This system worked well for the higher elements. So it worked very well for the higher elements like lithium, sodium, potassium were brought together. Okay, and it relates the properties of elements to their atomic mass. So the atomic mass and the properties of elements were related And for the first time, it was shown that there is a distinct periodicity in the properties of elements. Periodicity means repetition of the characteristics. So Newland was honored in 1887 by the Royal Society. Okay, he was given a Davy Medal for his work on classification of elements. But of course, very soon, Newland's law of octaves were also discarded. Why? Because it did not work with heavier elements, that is the elements lying beyond calcium. As more and more elements were discovered, they could not be fitted in Newland's octave, and Newland adjusted two elements, cobalt and nickel, in the same slot, and these were placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. Okay, the properties of fluorine, chlorine and bromine were completely different from cobalt and nickel. And iron, which resembles cobalt and nickel in properties, has been placed very far away from these elements. Now, cobalt and nickel, you know, they are metals, and fluorine, chlorine and bromine are non-metals, but yet they were placed in the same slot. So that was the reason why the law of octaves was discarded. So children, we are going to stop here today. Please go through the chapter in your textbooks and check the classification done by Newland. That is on page number 79 of your textbooks. And if you have any problem, we do have the WhatsApp group. Stay safe, children. God bless you.